Umair, is there any improvement? Fahad, you have submitted 5 assignments. Good. Any other assignment, Fahad, you have done?
Good evening, sir.
Good evening, Fahad.
So, assignment 7 is of inverse trigonometry. I couldn't do it.
Okay, that is a thing of function with respect to another.
Yeah.
Yeah, okay. So I guess there is one question which is not of inverse. Okay, so you can do that question. Rest of the questions we can do later on once we will
And
do the, yeah,
assignment 8, I did half.
you did half. Okay, so please share with me first so that I can update the status here. Okay. Okay, and whatever the doubts you have in the questions, we can discuss that after the class. Okay. So let me start the presentation.
Yes, sir. Can you hear me?
Yes, Fahad, I can hear you.
Yeah. Yeah, assignment 8, I will do it today.
Okay, Fahad, good. And there is one more assignment in which I have given the questions from the miscellaneous of your NCRT. So please do that assignment because there are some tough questions in that. And in case you have any doubt, we can discuss the questions after the class.
Okay, sir.
Okay, so we have started continuity in the last class, and then I have given some homework from the slide. Anyone has completed those homework? Not yet. So please complete those questions first, okay? And share with me, and then start the assignments. These are very good questions, okay? Very important questions. So please don't leave these. Please complete these one. Okay, so continuity we have completed in the last class. Okay, next we will start the differentiability. In differentiability, first of all, we will understand the formula, that what formula we have to use. Okay, and after that, we will try some questions, 2 or 3 questions, and then we will check the graph. We will try to understand this differentiability from the graph. Okay, so first, in this slide, I will discuss the only formula with you. What's the concept behind that? That we will understand in the graph portion. Okay, so please check here. Let fx be a real value. And Umir, I guess you have some doubt. So we can discuss that after the class. Now let fx be a real valued function defined on an open interval AB. Okay, you have a function fx, and in this interval it is defined. Okay, and we have a value c which belongs to this interval. Okay, so fx is a real valued function which is defined on an open interval this, and there's a point c which belongs to this interval. Then fx is said to be differentiable. Fx is said to be differentiable at x is equal to c if this limit x tends to c fx minus fc by x minus c exists. We will say that this function exists if this limit exists. Okay, how we are getting this limit and what this, okay, and how we are getting this limit, that we will discuss later on in the graph. Okay, so we need to remember that a function is differentiable at x is equal to c if this limit exists. Okay, now this is a limit, so anyone can tell me when a limit exists, when we will say that a limit exists. You have done many questions in continuity. So anyone can tell me when we will say that a limit exists. Yes, Fahad, when you will say that there is a limit and it exists, what is the condition?
When it is continuous.
No. Continuous is a different topic. Limits is a different topic. Okay. We, for continuity, for function to be continuous, that limit should exist and that should equal to fa. That's correct. But a limit exists or not, that completely does not depend on completely does not depend that a function is continuous or not. Okay. So you have done the questions on the basis of this, in which case we will say that a limit exists. Rifat, when we will say that a limit exists. Amir, no, you have done questions when you are finding a limit. Then when you will say this limit exists or not. Suppose you are finding this limit, limit extends to a fx. When you will say that this limit exists or not. Hmm? When the LHL and RHL are equal. Hmm? We have done this in limits that when LHL left hand limit and right hand limit are equal, then we will say that the limit exists. Okay. Now here we are saying that this limit exists, then fx is said to be differentiable. Then that means if we are approaching the value c from the left side and right side, both should be equal. In case of limits, we had said this is a left hand limit. In derivative, we will say left hand derivative, LHD. Okay, LHD is left hand derivative because we are doing the derivative here. Okay, so this limit exists. This limit is called the derivative of fx. Okay, this limit is called the derivative of fx at x is equal to c, and it is denoted by f dash c. Now, this one, limit extends to c minus fx minus fc is called the LHD of fx at x is equal to c. Okay, if you are approaching this value from the left side, this is called the LHD, left hand derivative. In limits, we say left hand limit. In derivative, we will say left hand derivative. So what happened in left hand derivative? We will approach the value from the left side. Similarly, x tends to c plus, this is called the RHD of fx. Okay, right hand derivative. F is differentiable at x is equal to c if left hand and right hand derivative are equal. So if LHD at x is equal to c is equal to RHD at x is equal to c, then we will say that the limit exists. Sorry, then we will say that a function is differentiable. Okay, I hope this is clear to everyone. Please note down this. We will solve a question on the basis of this formula. Then this formula will get clear to you. Okay, please note down this and raise your hands once it is done. Everyone, please raise your hands once it is done and let me know if you have any doubt in this.
So the formula is in third point.
Uh, First, what's the question?
No, no, the formula is in third point.
Formula is
Formula
this.
form.
Main formula is this. This should exist. When it will exist? When this left hand limit and right hand limit will be equal. Okay. So we will calculate left LHD and RHD both. Okay. I will explain this to you by taking an example. Okay, so all of you, please raise your hands once it is done. Okay, Fahad, good. Umair and Rifat, please raise your hands if it is done. Okay, Rifat, good. Umair, please raise your hand if it is done.
Sir, I'm still writing.
Okay, Umair, I will wait. And Umair, whatever the doubts you have, we will discuss after the class. Okay.
Sir, done.
Done. Okay, good. Now, for example, this question, fx is equal to mod x is not differentiable at x is equal to 0. Okay, we need to show that modulus function is not differentiable at x is equal to 0. So whenever you get a mod to solve it, we need to define it. Fahad, can you tell me how can we define the mod? Fahad, can you tell me how can we define a mod? Rifat, how can we define this mod? We have already discussed the modulus questions. Umair, can you tell me how can we define this mod? No one? Please check here. X is greater than equal to 0. This is x. And when x is less than 0, okay, minus x. This modulus we have already discussed in our previous classes. I'm again explaining to all of you. Please check here. You all know that property of modulus, whenever you will put any value inside the modulus, it will convert that value into a positive value. Okay, whatever the value you will put here, it will convert that value into a positive value. For example, if you will put a 2 here, then this will give you 2. If you will put a minus 2 here, it will give you a 2. So whatever the value you will put inside this mod, it will convert it into a positive value. But what is the formula of mod? How the mod work? How it convert every value into a positive value? So the formula is whenever you will take any value, then mod will check that value is positive or negative. For example, if you're putting a positive value, then mod will check that what value you have put. Okay, it is a positive. Then what it will do, it will take the value, it will take the formula as x. If you're putting a positive value, then modulus will take the formula as x. Okay, so now in this formula, put this value 2. What you will get? Final answer is 2. So it's a positive. Now, if you will put a negative value, for example, minus 2, so mod will check this is a negative, then mod will take this formula, mod x is equal to minus x. Okay, so mod will check what the value you are putting. If you're putting a negative value, then mod will take the formula as minus x. Now, in place of this minus x, please put the value. So what you will get here? Minus, in place of x, put minus 2. What the final answer you get? This is 2. Okay. So how the mod is working? Mod is working like this. Is it up there? Redmi Note 9 Pro Max. Abdur or Zed? Okay. Okay, so Umair, Rifat, and Fahad, this is clear how the mod work. Mod will check that what the value you are putting. If you are putting a positive value, then modulus will take the formula as x. If you are putting a negative value, then modulus will take the value as minus x. Take the formula as minus x. Now we will summarize these two results. Then what will happen? If you're putting a value x is greater than equal to 0, so that means you're putting a positive value. So what the formula this modulus will take? It will take as x. If you're putting a value which is x is less than 0, what the formula mod will take? It will take as minus x.
Accurate.
Okay. Is it clear, Umair, Fahad, and Rifat?
Yes, sir.
Okay, good. Rifat and Umair, is it clear? Okay, Rifat, very good. Umair? Umair, is it clear?
Yes, sir.
Okay, good. Okay, Zed, you were not present in the last class, I guess. Zed, you were present. Okay, okay. So did you check the recorded lectures? Zed, did you check the recorded lectures? If not, then please check those lectures. Okay. Okay, okay, okay. So we have completed continuity in the last class, and hopefully today we will complete the differentiability. Now, modulus is what? Modulus is this. Okay. Now we need to show that this is why it would be minus x if it's less than yes, yes. Yeah, Umir, how the modulus work? We need to check how modulus is converting every value into a positive value. So if you are putting a value which is, for example, minus 3, putting a value negative, then what will happen? Modulus will take the formula as minus x. Okay. Now in this formula, put minus 3. So minus is there in the formula. In place of x, you will put minus 3. So you're getting a 3. Okay. If you're putting a positive value, for example, x is equal to 2, then the formula will be x. If you will put in place of x this 2, you will get a 2 only. So how the modulus work? Modulus work by these two formulas. It will check what the value you are putting. If you're putting a negative value, then it will use the formula minus x. Okay, negative means less than 0. That's why I have written for x is less than 0, mod x will be equal to minus x. Is it clear, Umair?
Yes,
Umair?
sir.
Oh, okay, great. Okay, so first of all, whenever you're getting a question in continuity and differentiability regarding modulus, then please always define the mod. So we have defined here. Now we will find the LHD, left hand derivative at x is equal to 0. Okay, so what is the formula? Limit. Z, please take a screenshot of this. Okay, this we have just discussed that what is a differentiability. I will explain this to you later on. Okay, Seth, please take the screenshot of this one. Is it done, Zed? Okay, okay. So Zed, when we will say that a function is differentiable, when this limit exists, x tends to c, fx minus fc by x minus c. If this exists, then we will say that function is differentiable. You know that when limit exists, when left hand and right hand are equal. In case of derivative, we will say left hand derivative and right hand derivative. So here the left hand derivative is x tends to c minus. Okay, fx minus fc by x minus c. What is RHD? Right hand derivative. X tends to c plus fx minus fc by x minus c. Okay, so if LHD and RHD are equal, then we will say that the function is differentiable. Okay, so here we are finding the LHD. So x tends to 0 minus fx minus fc. In place of c, we will put 0 by x minus c. Okay, please check with this formula. For LHD, we have this formula x tends to c minus fx minus fc by x minus c. So in place of c, you have 0. That's why we have put this formula, fx minus f0 by x minus 0. Okay. Now, who can tell me, Fahad, for this one, for LHD, which function we will choose, the first one or second one? Fahad, for LHD, which you are not audible for?
Yes, sir.
Yeah, so I'm saying that for LHD, which function we will choose, the first one or second one?
Second one.
Second one, very good. So all of you, please check here. Here it is, x is less than 0. Less than 0 means we are approaching from the left side. Okay. Less than 0 means negative. So 0 minus means we are approaching from the left side. So that's why we will take second function here. So we will write like this, limit x tends to 0 minus fx means minus x minus f0. So we have taken this function fx is equal to minus x. So what is the value of f0? Rifat? Rifat, what is the value of f0? Okay, Zad, okay. Rifat, can you tell me what is the value of f0 here? Fx is this, then what is the value of f0? Uh, Umair, can you tell me what's the value of f0?
So it's
Okay,
zero, right?
okay, good. Good, Rifat, good. Umair, this is 0 by x minus 0. Okay, now what we will do, we will put for LHL, you already know that we will do in this way, put always x is equal to 0, 0 minus h. Okay, and in the bracket, right, when x approaches to 0 minus h approaches to 0. What we will get here, limit h tends to 0 minus, in place of x, we will write 0 minus h. We can ignore the next 0. This is 0. X minus 0 means 0 minus h. So this will give you what? Limit h tends to 0. Open this bracket, you will get h. Here you will get a minus h. Cancel out this h. So you will get limit h tends to 0. And here you will get a minus 1. So this is equal to minus 1. Okay. So I hope this is clear to everyone. Please note down this and let me
Sir,
know once it is done. Yes, Umair?
sir, why are you equals to 0 minus h?
0 minus h. Okay. So in the limits only, Umair, I explained to you that to solve the limit, we have a two method. First is a direct method, okay, where we directly put the limit and we have some formulas. Second is LHL and RHL method. So whenever you have a inequality or you have a modulus question, always use LHL and RHL concept. Okay, because if you will proceed from the left side, you have a different function. When you will approach from the right side, you have a different function. Okay, that's why we have to take both the functions. We have to take LHD and RHD. Omir, you were present in the class when I had explained about the LHL RHL concept and limits. Omir, you were present in the class?
Yes, sir.
Okay, okay. Then I hope you have done this. Okay, so whenever you have an inequality and a modulus question, always take LHL and RHL concept. Okay, Zad, so your doubt is how you have put the value of H. Okay, Zad, please check here. It is minus 1. Okay, there is no H in this question. That's why we can't put it. Okay, so means there's no H here. That's why the answer will remain the same, minus 1. In case we have a H here, then we can put that value. Okay, Zad? How minus 0 minus H? Zed, please check here. For LHL, from when you will approach from the left side, always put 0 minus H. When you will approach from the right side, put 0 plus H. So in this formula, we have minus X. So write minus 0 minus H. In place of x, we have put this value 0 minus h. Okay, Zed? Okay, Abdur, you have joined 25 minutes late. Why? Now, all of you, please note down this. In the same way, please try to find RHD. For RHD, you need to put 0 plus h. Please try to find RHD. Tell me the answer. If you will have any doubt, I will solve it. Okay, okay, Abdur, no issue. So, all of you, please note down this and try to find RHD. Okay, Abdur, I will explain this to you in 1 or 2 minutes once everyone will note down this slide. Please try to find RHD. Everyone has completed, has noted down this slide. Okay. Good question. So we will again go back to the that is correct. Very good. So LHD is not equal to RHD Z. So we will say that a function is not differentiable at x is equal to 0. Okay, then what we will do first, we will again check the concept of differentiability. Okay, so what is a differentiability? Let fx be a function and we have this which is defined in this interval and we have a value c which belongs to AB. Fx is said to be differentiable at this point c if this limit exists. Limit x tends to c, fx minus fc by x minus c exists. We will say that a function is differentiable when this limit exists. Okay, so Abdur, you already know in the chapter in from the concept of limit, when we will say the limit will exist when left hand and right hand are same. Okay, Abdur, this I already explained to you that when a limit exists when left hand limit and right hand limit are equal. Okay, now in case of differentiability, we will say left hand derivative. In limit, we will say left hand limit. In differentiability, we will say left hand derivative. Okay, Abdul. So when we are taking the limit from the left side, we will say left hand derivative. Now, this limit is called the derivative of fx at x is equal to c and is denoted by this sign. Okay, when you will calculate this limit, this is only called the derivative. Now, this x tends to c minus fx minus fc by x minus c is called the LHD, left-hand derivative of fx at x is equal to c. Okay, this one, limit x tends to c minus fx minus fc by x minus c is called the left-hand derivative of fx at x is equal to c. Similarly, x tends to c plus fx minus fc by x minus c is called the right-hand derivative of fx at x is equal to c. Okay, Abdul. So when we are taking this, you are getting one very good for that is correct. Okay, then when you are taking from the left side, you will say left hand derivative, right hand derivative. When these two are equal, then you will say that the function is differentiable. F is said to be differentiable if LHD is equal to RHD. Okay, so Z, sorry, Abdur, can you take a screenshot of this? Okay, Fahad, perfect. This is correct. Abdul, can you take a screenshot of this so that we can check the question? Okay, great. So Fahad has done this. Zad, you have completed this question. Umair and Rifat, please let me know once it is done. Okay. Now we have this question. We need to show that modulus of x is equal to mod x is differentiable at x is equal to 0 or not. Very good. This is correct. Very good. Now next one. Okay, Umair, please complete it and let me know what the answer you're getting. show that fx is not differentiable. So what we will do, we will find limit x tends to LHD at x is equal to 0. Okay. We will first of all find LHD at x is equal to 0. So for LHD, we will use the same formula which is given here. This one. Limit x tends to c minus fx minus fc by x minus c. So here we have 0 minus. In place of c, we have this. Limit fx minus f0 by x minus 0. In this question, I missed one step. First, for the mod question, we need to define it. This is equal to what? X when x is greater than equal to 0 minus x when x is less than 0. Now, Abdul, please tell me for left-hand derivative, which function you will choose, the first one or the second one?
Second.
Second one, very good. So limit x tends to 0 minus. Second is minus x minus f0, okay, by x minus 0. Now put this value, limit x tends to 0 minus. Now you have the function f, you have taken minus x. So Abdul, what is the value of f0?
Zero.
Very good, 0. So this minus x remain as it is. Here we will put 0. Here this not c, this 0. X minus 0. And you know how to solve a limit, put x is equal to 0 minus. Okay. For left hand, we always solve like this. In the bracket, please write when x approaches to 0 minus h approaches to 0. So what you will get here, limit h tends to 0 minus 0 minus h minus 0 by 0 minus h. Okay. So here you have limit h tends to 0. Open this bracket, you will get h here. By here you have minus h. So cancel out this, you will get limit h tends to 0. Here you have a minus 1. So here you will get a minus 1. Okay, Abdul, is it clear?
Yes, sir.
Okay, great. So Abdul, please note down this. Okay,
Done.
done. Okay, great. Rifat, did you get the answer? Umair, did you get the answer for the RHD? Okay, Rifat, what the RHD you are getting? Rifat, what is the value of RHD? So Umair, for RHD, we will use 0 plus fx minus f0 by x minus 0. So for RHD, Rifat, sorry, Abdul, which function we will choose? First or second?
The first.
First one, very good. So we will write here, this is equal to limit x tends to 0 plus x, okay, minus what is f0?
0.
0, very good, by x minus 0. Again, the same thing put, x is equal to 0 plus h. The bracket write when x approaches to 0 plus h to 0. So this is equal to limit h tends to 0, 0 plus h by 0 plus h. So what you will get here, limit h tends to 0, h by h, cancel out this h, what you will get here, limit h tends to 0, 1. So if you will put this, you will again get a 1. So LHD at x is equal to 0 is not 0 is not equal to RHD at x is equal to 0. Hence, fx is not differentiable, is not differentiable at x is equal to 0. Okay, Abdul, is it clear?
Yes.
Okay, great. So please note down this. Umair, are you getting the same answer?
Yes, sir.
Great, great. So Abdul, please raise your hands if it is done so that we can start the next question. Okay, great. All of you, please try this question. Show that this function is not differentiable at x is equal to 2. Okay. Okay, Rifat, please try this question. Okay. You have to check first for x is equal to 2. Okay, so the same thing. First find LHD at x is equal to 2, then find RHD and check these two are equal or not. Okay, Zed, very good. So Zed, what is LHD you are getting here? Okay, great. Very good. So Umair, Abdur, Fahad, and Rifat, please share your answer if this is done, or let me know if you have any doubt in this question. Okay, Abdur, very good. Abdur, what is LHD? What is LHD you are getting? And what is RHD? No, that's not correct. LHD should be 1 and RHD should be 2. Please again check the answer, Abdur. Okay, LHD should be 1 by, is it LHD 1 and RHD 2? You are saying this, Abdur? Okay. Fahad, Rifat, and Umair, please share your answer if it is done. Okay, no issue. We will solve it. So we will find LHD at x is equal to 2. Okay, so we will write limit x tends to 2 minus fx minus f2 by x minus 2. Okay, so first, can you tell me for LHD which function we will choose?
First one.
First one, 2 minus, yes, that's correct. So x minus 1, okay, minus f2 by x minus 2. So here we have limit x tends to 2 minus. In play, we have this x minus 1. What is the value of f2? You have this function fx is equal to x minus 1. So f2 is what? 2 minus 1, which
2.
is 1. 1. Okay, x minus 1, so 2 minus 1 will give you 1 by x minus 2. So for LHD, put x is equal to 0 minus 2. Okay, so in the bracket, please write when x approaches to 2 minus h approaches to 0. So here you will get what? Limit h tends to 0. In place of x, put this value 0 minus 2. Okay, in place of this x, put the value 0 minus 2, minus 1 you have, and minus 1 by x minus 2. Here we will put 0 minus 2, okay, minus 2. So here do the calculation, h tends to 0, minus 2, minus 1, minus 1, minus 4, minus 4. Cancel out this, you will get limit h tends to 0, 1, okay. So you will get a 1 here. So LHD is 1. Okay, Fad? It is clear?
Yes.
Okay, now similarly, Fad, please find RHD and share your answer. Abdur, is it clear, the LHD?
Yes.
Okay, Abdur, now please check the RHD. RHD should be 2. And Umair and Rifat, uh, please share your answer if it is done. So Umair, Abdur, Fahad, Rifat, please tell me what the RHD you are getting. Okay, Rifat, no issue. I will do this. RHD at x is equal to 2. No, Umair, it is not correct. Please check here. Limit x tends to 2 plus fx. No, Umair. No, Umair, it is not correct. Fx minus f2 by x minus 2. Okay. Now, Rifat, for RHD, which function you will use, the first or second? Rifat, for RHD, which function you will choose, first or second? Second, very good, which is 2x minus 3. So here we will write 2x minus 3 minus f2, okay, by x minus 2. Now, limit x tends to 2 plus 2x minus 3 minus f2. f2 means put the value here. 4 minus 3 means 1 minus 1 by x minus 2. Next, put x is equal to 2 plus h. In the bracket, please write when x approaches to 2 plus h approaches to 0. So here what you will get, limit h tends to 0, 2 into in place of x, 2 plus h minus 3 minus 1 by 2 plus h minus 2. Limit h tends to 0. Open this bracket. So 2, 4 plus 2h minus 3 minus 3 minus 1 by 2 plus h minus 2 will give you h. This is equal to limit h tends to 0. 4 minus 3 minus 1 will give you 0. So 2h by h. Cancel out this h. You will get limit h tends to 0. Okay. It is 2. Okay. So there is no h. That's why you will get a 2. So LHD at x is equal to 2 is not equal to RHD at x is equal to 2. Hence fx is hence hence fx is not differentiable. It's not differentiable. Okay. Differentiable at x is equal to 2. I hope this is now clear to everyone. Yes, Rifat, your answer is correct. Very good. So all of you, please note down this and confirm. Then we will start the next question. Okay. So Umair, Abdur, Fahad, please raise your hands once it is done. Yes, Fahad, is there any doubt?
Yes, sir. So
Yes.
instead of x, we are taking 0 minus 2 in LHL. And
In
in RHD, we are taking 2 plus h. Why so?
in oh, I'm sorry. This is a mistake I've done. Sorry. We have to put 2 minus h. X is equal to 2 minus h. Okay. So here you will get a 2 minus h minus 1 Okay, minus 1 by 2 minus h minus h, sorry. Two minus h minus 2. So limit h tends to 0. 2 minus 1 minus 1 is 0. So minus h by minus h. So limit h tends to 0. Here we have 1. So final answer is okay. Thanks, Fahad. So this is the final answer. Okay, Abdur, your doubt is h is 0. So why can't we substitute it? Abdur, we will not substitute the value of it directly. First of all, we will simplify it. Okay. So if we will check this case or the later one, if you will put here only, you will get a 0 by 0. Okay, that's why we are not putting here. We have solved it. Then finally we will. Okay. So please complete this and confirm me once it's done. Then we will start the next. Abdur, is it done? In previous, we used 2 minus h, which are it we should yes, we have done. Please check here, Abdur. Here we have used 2 plus h. In the previous one, sorry, I've done a mistake, so I've corrected it. It is 2 minus h. Okay, Abdur?
Yes, sir.
Okay. So shall we move to next question?
Yes.
Okay. Umair, shall we start next? Fahad, shall we start
Wait,
next
sir, I'm
question?
writing. I'm
Oh,
writing.
okay,
Yes,
okay,
sir, done.
okay, okay. Okay, Umair, I will wait. Umair, is it done?
Yes, sir.
Okay, great. Now, please try this question. Show that fx is equal to x square is differentiable at x is equal to 1. Okay, please try this. All of you, please let me know the answer. Okay, what the LHD and RHD you are getting. Yes, that F is equal to 2. Okay, derivative is 2. Good. So that means LHD and RHD both you are getting as a 2. Very good. Okay, very good. So Rifat, what the answer you are getting? Rifat, what is the answer you're getting? 2. Very, very good. Very good. Okay, so Umair, Fahad, and Abdul, please share your answer if it is time. Umair, Abdul, and Fahad, please let me know if you have any doubt in this question. Okay, Fahad, I will. Okay, so fx is differentiable at x is equal. Show that this is differentiable. Okay. Now here we have only a single function. So we will take x square in both the cases. LHD at x is equal to 1. So limit x tends to 1 minus fx minus f1 by x minus 1. So we have x square only. So we will put limit x tends to 1 minus x square minus f1 means 1. Me the next question. Okay. Zed, I think I will not give you a next question. I will start. No, I need to start a new topic. Okay. Okay. You can complete your work and you can join later on. X minus 1. Now, again, the same thing. Put x is equal to 1 minus h. In the bracket, please write when x tends to 1 minus, x tends to 1 minus, h tends to 0. Here you will get what? Limit h tends to 0. X square means 1 minus h whole square minus 1 by 1 minus h minus 1. Limit h tends to 0, 1 plus h square minus 2h minus 1. Okay, Abdur, this is a very good question. Always remember for differentiability, okay, in case of differentiability, we have only this method, left-hand derivative and right-hand derivative. Okay, for differentiability, we have only a single method, that is LHD and RHD, left-hand derivative and right-hand derivative. So whenever we need to check that a function is differentiable or not, we have to use this method only. There's no other method in differentiability. Okay. Okay, for a minus b whole square, a square plus b square minus 2ab minus 1. Okay, this minus will cancel out, so minus h. This will cancel out. So here you have limit h tends to 0. And here you will get what? Uh, take h common here. So you will get h minus 2 by minus h. Okay. So this is limit h tends to 0. Limit h tends to 0. Cancel out this h. So you will get h minus 2 by minus 1. Okay. We will put this h here 0, 0 minus 2. 0 minus 2. And you can put this minus 1 here. Okay, so final answer you're getting 2. So LHD is this one. Okay, first I've put this formula a minus b whole square. So this is LHD. Now in the same way you have to find the RHD. So who have a doubt here? Fahad, okay. Fahad, in the same way, please calculate RHD and tell me the answer. Umair, Abdul, please calculate the RHD and tell me the answer. Okay, Abdul, what we have done here, take h common, cancel out this h. We have minus 1. Here we have minus 1. In place of h, put 0. 0 minus 2. And this negative we can write here. So we are getting 2. Okay, Abdul?
Yes, sir.
Okay, great. So can we start? Please calculate RHD now. Okay, okay, Zed. No issue. Okay. Okay, Zed, you're welcome. Fahad, Abdur, and Umair, please tell me what the RHD you are getting. Umair, Fahad, and Abdur, I am waiting for your answer. Please calculate RHD. No, Abdur, that's not correct. That is also a 2. Okay, so check here, RHD. Very good, Fahad, that is correct. RHD at x is equal to 1. Okay, now here again the same thing. Limit x tends to 1 plus fx minus f1 by x minus 1. It is equal to limit. We have only a single function here, 1 plus, so we will write x square. F1 means 1 by x minus 1. Put x is equal to 1 plus h. So here we will get what? 1 plus, here we will get limit x tends to 1 plus. In place of x square, we have 1 plus h whole square minus 1 by 1 plus h minus 1. This is equal to why we have x1 plus here. Limit h tends to 0. Okay. The same thing when x tends to 1 plus h tends to 0. So what you have got here, limit h tends to 0 and 1 plus h square plus 2h minus 1 by 1 plus h minus 1. 1 cancel out, 1 cancel out. So you get here limit h tends to 0. So h square plus 2h by h tends to 0, h plus 2 by h. Okay, cancel out this h. So you get what? Limit h tends to 0, h plus 2. So this you will get 0 plus 2, which is 2. Okay, so LHD at x is equal to 1 is equal to RHD at x is equal to 1. Hence, fx is differentiable at x is equal to 1. Okay. And this f dash 1, this is equal to 2. So I hope, Abdur, this is clear to you. Umair, I hope this is clear. You need a break of 5 minutes. Okay, so all of you, do you need a break? Okay, so please come back in 5 minutes. Okay, I'm giving you a break of 5 minutes. Please come back in 5 minutes. We need to extend our class. Please check the time and be back in 5 minutes. Okay, so I'm back. Fahad, Umair, Abdul, Rifat. Shall we start next? Oh, okay, Abdul, Rifat. Good. Umair and Rifat. Shall we start next? Okay, so this question is homework.
So we should define this first, right?
Yes, that's correct. The similar type of question we have done in continuity, okay, where we have defined the mod and then we have solved it. The same thing we have to do here. Okay, Umair, are you back? Rifat. So, okay, Rifat, good. So Rifat, please note down this. This question is your homework. Umair, please note down this. This is a homework. All of you, please raise your hands once you will note it down this so that we can start the next question. All of you, please raise your hands if you have noted down this. Okay, Rifat, very good. Abdur and Fahad, this is a homework. Okay, Abdur, good. Fahad, shall we start next? Umair, are you back?
Yes, done, sir.
Okay, Fahad, good. Umair, please reply me once you are back. Again, this question is also homework. Very simple question. There is a mod, you need to define it. Oh, okay, Umair. So, Umair, please note down this, then I will change the slide. Okay. Please note down this. This is your homework. This question came in CBSE 2020. Okay. So I will give you the hint. You have this x mod x. Okay. So just define this. When x is greater than or equal to 0, this x remain as it is. In place of mod x, you have x. So x square. X is less than 0. X into minus x, you will get a minus x square here. Okay. So all of you, okay, Rifat and Abdul, you have done. Fahad and Umair, please raise your hands once you will note down this question.
Done.
Okay, great. Fahad, is it done? Okay, great. Umair, did you note it down the last question? This one?
Yes.
Okay, great. Okay. Now we will discuss the theory behind that formula fx minus c by x minus c limit x tends to c. Okay. So yeah. Suppose we have a function. This is x. Suppose we have this function fx. Okay, that is y. Suppose this is a point P. Okay, and the x coordinate at this point is C. Anyone can tell me what is the y coordinate at this point? Anyone can tell me what is the y coordinate at this point? Y coordinate should be
Sir, P.
FC. Okay, if this is a function fx, we always write y is equal to fx. Okay, in place of x, if you will put c. So y is equal to what? FC. So that's why this is FC. We need to find the tangent at this point. So for that, what we will do, we will take a point A here. Okay, and we will take a coordinate as C plus H. If this is C plus H, then here you will get a C plus H. Okay, you get this AP. Okay, AP is C plus H. We will find the slope of this tangent. So anyone remember the slope of tangent formula of class 11? In class 11th, you have done a formula, slope of tangent. Anyone can tell me that formula? Yes, yes. Tan theta is equal to what? Y2. Yeah, one was the form. No, was the equation. Y is equal to mx plus c. Slope of tangent AP is equal to, yes, y2 minus y1 by x2 minus x1. Okay, so here we will take this as the y2. So f c plus h minus y1, we will take this fc. We have this formula y2 minus y1 by x2 minus x1. This you have done in class 11. fc by x2 c plus h minus c. So here we will get what? fc plus h minus fc by h. Okay, so we get this slope of tangent AP. But what if we need the slope at this point P? Then we will move this point A to very, very close to P. Okay, now this point A depends on H. So if we will put this value of H, if this H is very, very small, then this point will be very, very close to P. So what we will do, if we need slope at point P, so this will be equal to limit, if we will put the limit h tends to 0. If the value of h is very, very close to, okay, we will write the same thing, c plus h minus c. C plus h minus c. So limit h tends to 0, the same thing, fc plus h minus fc by c plus h minus c. Okay. So this limit h tends to 0, fc plus h minus fc by c plus h minus c. So this will give us the slope of tangent. Slope of tangent at point P. At point P. Okay. Now, if we will take one more point here, let this be, suppose this is B, and the coordinate is C minus H. So next coordinate will be FC minus H. If we will find the slope at this point, the slope of AB, slope of PB. Okay, sorry. Okay. Slope of PB, and here also it is better if you will write slope of AP. Slope of PB is equal to what? FC minus H, same formula, Y2 minus Y1. C minus H minus C. Okay, and limit this is H tends to, sorry, not. So slope of PB is equal to this. Now, if we need this point B will be very, very close to P, then what we will do, we will take H very, very small. So we will put this limit H tends to C, FC minus H minus FC by C minus H minus C. And this will give us the slope of tangent at point P. Okay. Now, so when we will put the limit, then we will get a slope of the tangent at point P. Now, both these should be same. This should be equal to this one. Why? Because both are the slope of tangent at the same point. So these two should be same. What is this? This is RHD. What is this? This is LHD. So what the derivative give you? Derivative give you the slope of tangent at that point. So if you're finding the LHD and RHD, if these two are equal, okay. So if you will say if LHD is equal to RHD, then there exists a unique tangent at point P. At point P. Okay, if LHD is equal to RHD, then there exists a unique tangent at point P, and fx is differentiable is differentiable at and fx is differentiable. Okay, at point P. So what is mean by LHD is equal to RHD, then or we can say what is mean by a function is differentiable, then that means at that point there exists a unique tangent. If I'm saying that a function is differentiable at a particular point, that means there exists a single tangent at that point. Okay, so if you're finding the LHD and RHD, then both should be equal. Slope of tangent should be same. Okay, then we will say that the function is differentiable. Then that means there exists a unique tangent. What will happen if at a point there are two tangent exist? Then we will say that the function is not differentiable. Okay, I hope you understood at least 60-70%. They will not ask you about this in the exam. Okay, but you should know that what's the logic behind it. So all of you, please note down this. And if anyone have a question, then please let me know. Okay. Okay, Umair. So Umair, what we have done here, we have taken a point P here. Okay, and this point is C. So if this is C, what should be the y coordinate? Y coordinate should be FC. Why? Because we write y is equal to fx. So y is equal to, in place of x, if you have put C, we will get a FC. We take a point A here, which is C plus H. So the y coordinate will be FC plus H. And we have calculated the slope of AB. What is slope? Slope is this formula, y2 minus y1 by x2 minus x1. Okay. So here we have find out the slope of AB, which is this one. Okay. Now, if we need the slope, if we need this point should be very, very close to P, then what will happen? Then can we do? We can put this value of H tends to 0 so that this point A will come very, very close to P. So what we have done, we have put this limit H tends to 0. So this gives us FC plus H minus FC by C plus H minus C. Now, what is this expression will give you? This one. This will give you slope at this point. Slope of the tangent at this point. Okay. Now, this is also called the RHD. So what RHD give us? It gives us the slope of the tangent at this point. Now we take one more point B here, which is C minus H, FC minus H. We calculated the slope of PB. Okay, so slope of PB is FC minus H minus FC by C minus H, this one. Now, if we will put H tends to 0, then this point is very, very close to P. So we have put limit H tends to 0, this. Now these two values should be same. Why? Because if you are calculating slope from this side at point P, or you're calculating slope from this side at point P, the slope should be same. Okay, slope should be equal at this point. So if a function is differentiable at a particular point, then we will say there exists a unique tangent. The tangent should be same. If your slope of this and this one are different, we will say that there do not exist a unique tangent, so the function is not differentiable. So at this point, there exists a unique tangent, and for that, LHD should be equal to RHD. Okay. So this thing I have mentioned here, if LHD is equal to RHD, then there exists a unique tangent, and fx is differentiable at that point. Okay. So I hope everyone understood some part of this topic. They will not ask you about this in the exam. Okay. Now, on the basis of this graph, we will check some more points. First of all, please note down this, raise your hands. Okay, then we will start the next topic. Everyone, please raise your hands once you noted down this. Okay, Fahad, great. Abdul, Umair, and Rifat, please raise your hands once it is done. Okay, Rifat, good. Umair and Abdul, is it done? Okay, Abdul. Umair, is it done? Shall we move to next slide?
Yes, sir.
Okay, great. Now, in the next one, we have just this. If LHD is equal to RHD, then there exists a unique tangent. Okay. So there should only be a unique tangent, then only we can say that a function is differentiable. Okay, now then we have some more points. Okay, unique tangent means there will be a single tangent. So what are the cases when the function is not differentiable? Two cases are there. First, that for example, at this point, this is the origin. At x is equal to 0, you can see this is the corner point. Okay, if you will calculate the slope of tangent to the RHD, you will get a 1, and LHD, you will get a -1. Okay, so if you have a corner point in any graph, if there is a corner point, that at that point there do not exist a unique tangent. Okay, at that point there do not exist a unique tangent. So please remember, one of the cases corner point. At the corner point, the function is not differentiable. This is the graph of modulus function. Okay, so we have checked that modulus function is not differentiable at x is equal to 0. So please remember, mod x at x is equal to 0 is not differentiable. So what are the cases when the function is not differentiable? First is corner point. At the corner point, the function is not differentiable. Second one. Second is if there's a break in the graph. Suppose you have this graph and the function is not continuous. There's a break. So at this point also, the function is not differentiable. So we have two cases. First, when there's a corner point, then the function is not differentiable. Second, if the function is not continuous at that point. If there's a break in the graph at that point, then we will say that a function is not differentiable. Okay. So now we will see some points. So first is, if a function is differentiable at a point, it is continuous at that point, but the converse is not necessarily true. So if a function is differentiable, it will be continuous, but the converse is not true. For example, if we will take this graph, there's a modulus function at x is equal to 0, this one. The function is continuous or not? Who can tell me? Abdur. Abdur, can you tell me that at x is equal to 0, the function is continuous or not?
Yes.
Yes, it is
Yes, sir.
continuous. But is it differentiable at this point?
No, sir.
No, because there is a corner point. So if a function is continuous, it is not necessary it is differentiable. But if a function is differentiable, then it will always be a continuous. Okay. Always remember, if a function is differentiable, then it will always be continuous. Why? Because a function is not differentiable in in 2 points only. If there is a corner point, if there is a break. So if a function is differentiable, then it will be continuous. But if it is continuous, then it is not necessary that it is differentiable. Umair, I will check your doubt just in a minute. Example, the same thing, mod x is continuous at x is equal to 0, but not differentiable. Why it is not differentiable at x is equal to 0? Because at x is equal to 0, we have a corner. So if in a graph you have a corner, then it is not differentiable. Umair, your question is how to identify if it is continuous or differentiable from the graph. Continuous, Umair, we have already discussed that if you can draw a graph without lifting your pen, then it is continuous. For example, this. Suppose I'm trying to draw this graph, I draw like this. pick my pen, then draw like this. So this is not continuous at this point. Okay. So from the graph, if you can, in a simple language, Umir, if in a graph, if you can see there's a break, it is not continuous. For differentiable, if in a graph at that point there is a break, at that point, if a function is not continuous, or at that point there is a corner point. So you need to check two conditions. If at that point there is a corner point, for example, this one, then the function will not be continuous. If there's a break at this point, for example, here, the function is not differentiable. Okay. I hope, Umir, it is clear to you now.
Yes, sir.
Okay. Next point. If a function is discontinuous, it will not be differentiable. Okay. We have already discussed. There are two cases when the function is not differentiable. First, corner point. Second is discontinuous. So if a function is discontinuous, it will not be differentiable. Third point. LHD is at any point P is equal to RHD at any point P, then fx is differentiable at point P. Okay, we have discussed if LHD is equal to RHD, then function is differentiable at that point, and it means there exists a unique tangent. We have already discussed in the graph that function is differentiable if there exists a unique tangent. Now, next one. In other words, fx is differentiable at a point P if the curve does not have P as a corner point. Okay, so we are saying that fx differentiable at a point P if the curve does not have P as a corner point. If there's a corner point, then the function is not differentiable. Next one, if a function is not differentiable, then we have a two case, either we have a corner point there or there's a discontinuity at that point. Okay, so these are the 4 points. Please note down this, raise your hands once it is done, and let me know if anyone have a doubt here. Everyone, please raise your hands if you have completed this. Okay, Fahad, good. Umair, Abdur, and Rifat, please raise your hands. Okay, Rifat, very good. Umair and Abdur, is it done?
I'm still writing.
Okay, okay. Okay, Abdur, very good. Umair, I'm just waiting for you. So once it is done, please let me know. Umair, is it done? Shall we start next now?
Yes, sir.
Okay, great. Uh, okay. So we will do the questions later on, okay? Because I need to close end your class in just 5 or 6 minutes. So these results I will explain to you tomorrow, okay? But please note down this, okay? Because tomorrow we need to start a new chapter, that is application of derivative. So in half an hour, we will try to complete these topics. A single topic is remaining in differentiability. Then we will start a new chapter. So please note down this because right now we don't have a time. And I need to end your class. Tomorrow I will explain you about this. Okay, just give me a minute. Uh, okay. Yes, please note down this. And then we will end the class once you will done this. Okay, okay. Then after this class, I will discuss the doubts. Okay. So anyone who have a doubt, then they can stay. Okay. I will discuss your doubts then. Please raise your hands once it is done. Okay, Rifat, very good. So Rifat, please complete the questions which I have given from the slide. Then try to complete the assignments. Okay. And do you have any doubt, Rifat? No? Okay, then if you wish, then you can drop off. Okay. I will just discuss the doubts after this. And tomorrow, all of you have a test of differentiation. Okay. Okay, you're welcome. The complete differentiation. Okay, for not continuity and differentiability, only differentiation. So we can say up to assignment 9. Okay. For do you have any doubt? Okay, okay, for then if you wish, you can drop off. Okay. Is it done? Abdur and Umair, you completed this? Please raise your hands, okay, once it is done. Please raise your hands once it is done. Okay, Abdur. Abdur, just give me a couple of minutes. I will check your doubts. Fahad, is it done?
Yes.
Okay, okay, okay. Umair, is it done?
No, sir, I'm adding the sixth point.
Okay, okay, okay. I will explain these points to you tomorrow.